Hello, everyone, and welcome to this Radcast on the topic of modeling and optimization of solutions. I'm very happy to be joined by my colleague, Michael, who's out in Thailand. Michael, how you doing out there?
Doing well, Jamin. Good to be here.
Great to see you. All right. Well, let's rock this. The topic today is modeling and optimization of solutions. Let's first kind of ground ourselves in where we're coming from with this. What's the context? The context is the goose that lays the golden eggs. The golden eggs are the solutions, all the solutions we need to save as much of life on Earth as possible and get off of this highway to hell that we're on and take the off-ramp toward utopia as a destination, as a telos. So we need a lot of solutions to get there, to do that. So we're focusing for the moment on later on later conversations or video conferences in this series. We'll focus on the myriad solutions. Right now, we're focused on the most urgent thing, which is building the goose. The goose that lays the golden egg. So what's inside this goose? Let's look deep inside the goose. Get inside there and see. What is the goose made of? Well, the goose is made up of a lot of things, people and platforms, but platforms can be divided up into four major stages: ideation of solutions, design of solutions, sing along, modeling and optimization of solutions, and implementation of solutions, which are the golden eggs. So we've already talked about in previous conversations on this series, ideation and design. Now let's talk about modeling and optimization. So, I'd like to talk about how modeling and optimization fits within, the broader panorama. I mean, if you look at this last image here, one could very easily form the impression that you need to have detailed design done before you can do modeling and optimization. Not so. Let me talk about a counterexample, okay? Imagine we wanted to model what would be the impacts of having fusion energy, right? At scale, providing electricity to the masses, including industry, including agriculture, including households. Electricity to the masses at a cost of a tiny fraction of a penny per kilowatt hour, right? Super cheap, virtually free, but not entirely free, because of course, these plants need to be built and maintained and, et cetera, et cetera. But that could be modeled with simply modeling the price of electricity and modeling new capacity. Imagine you do it at the level of SimCity. Why not, right? Imagine an advanced SimCity simulator that simulates a city that explicitly models for electricity, right? And look at all the things that change if you lower the price of electricity, right? Well, that's basically what we're talking about, modeling in the case of the fusion example. And, why is that valuable? Well, goodness, just consider if with a truly holistic global model of the whole world, we will be able to see myriad impacts and cascading impacts of that cheap form of electricity. What were the parameters we had to input into the model? Well, in its simplest form, just the price per kilowatt hour, which, as I said, it could be a tiny fraction of a penny. You can just dial it down to whatever the best estimate is, but it's a very low price for fusion energy. And then, anyway, I've kind of beat that one to a pulp, but it also includes the design, not just of the thing itself. Like take for example, my iPhone. It's not just the design of the thing; it's the design of the life cycle. iPhones are designed to have a very short life cycle, which is a big tragedy. They could be built to last. The design of the impacts of the the product, or designing for impact. So, for example, just consider all the negative impacts iPhones have had on, you know, people psychologically and socially in so many ways. I'm not saying they haven't had benefits, like the spaghetti factory with blue and red. You know, it we need to, you know, model all these impacts and then adjust the design accordingly. Change the design of the life cycle, right? Change the design of usability, change, you know, lots of things. So modeling and optimization affords us that opportunity to make mistakes in the virtual world so that we don't make those mistakes in the real world. And let me, in a moment here, just kind of share, you know, where modeling and optimization fits into the chain as we've seen it previously, right? Just to kind of get a richer context for it, right? So let's start somewhat arbitrarily with the asynchronous form of communication of brainstorming. And then we saw how, I'm just going to kind of walk through a brief history of radical collective intelligence to the moment, just to bring us up to where exactly modeling and optimization plugs in. What does our world need to be whole? Wholeness for people, wholeness for the planet. And please jump in anytime, Michael, even as I'm presenting this, okay? So we broke this all the way down to leaf node needs, including the need to remove ice from power lines, the brain swarming example in Dr. Tony McCaffrey's video. And we saw how we are able to root down to myriad different possible solutions and model their various impacts, positive and negative. And then how we went from there to, after a brief trip into the dialectic between synchronous conversational domain and asynchronous brainstorming domain, how we can manifest all kinds of solutions, even very quickly, by directing the right resources to them. And that's a combination of human beings collectively directing resources as well as AI, right? Operating symbiotically. And now, then all these solutions need to be modeled. You need to say, what are all the results? What would all the results, what would all the impacts be of implementing this solution in the real world? And that's where you basically run a SimCity-like simulator, like simulation, like run. Well, let's test it out. That would show us solution by solution, but also we can do it by sets of solutions, groups of solutions, which of course introduces a very interesting, arguably daunting combinatorial problem of which combinations of solutions should we go with, right? In what sequence, in what order, not just designing the set of solutions, but designing the entire implementation plan. You know, I often marvel, for example, at the island of Singapore, that went from this jungly little island floating around the Pacific to this industrial giant, right? Which is routinely compared with, you know, on the level of Hong Kong, Taiwan, you know, South Korea, you know, as one of the Asian tigers. Indonesia, it's this tiny little island. You can jog around the whole thing in a day, right? If you're a decent runner. Literally, you can circumnavigate the whole thing by foot in one day. How on earth, right? Well, there were a bunch of stuff that was implemented in Singapore, right? In very well orchestrated ways, right? So we're talking about, anyway, so imagine modeling all that. Imagine that that was somehow close to an optimal, right? Anyway, I'm going to go on mute because I've been talking a lot.
Yeah, it actually reminds me of a interesting news story I heard. I think it may have been yesterday about, or today for that matter, about the ability to get ahead of the cholera outbreaks that have been happening in Yemen because of the civil war down there. And what they've been able to do is use weather patterns and other local indicators to predict outbreaks in the future by up to a week or two.
When it rains, it spreads. When it rains, it spreads.
Yeah, and other local factors, and they're looking for ways to be able to get even further ahead, so they can find ways, even amidst the war, to vaccinate against it and to get to those locales in time. So, that's like a very small scale example of something that has multiple variables, but they run a certain kind of simulation, as does the weatherman, and take that and mash it up with local data sets, and they're able to turn the tide on cholera outbreaks. Imagine doing that on a mass scale, right? That take into account just massive amounts of data, and local and global, yeah, I mean, things are now becoming possible that hitherto were seemed like sci-fi, but it isn't too soon, right, for us to be able to develop these kinds of robust simulators and optimizers, because the problems are compounding at such a rate that we need a correspondingly how do I say, exponentially powerful platform, right, for solving said problems.
Yeah, totally. Oh my goodness. So, yeah, it's just such an exciting and dynamic part, and what a powerful tool. I mean, if we can simulate properly, accurately, we can get immediate feedback on solutions, even in the concept phase. Like I was talking about for fusion energy. Hey, how valuable is this concept? If it's so valuable, oh my goodness, no, we could have all these positive impacts, not just financial, not just measured financially, but in terms of saving life on Earth, saving as much of life on Earth as possible. So, with all those positive impacts, we simply cannot afford not to do it. So really, we should be diverting and directing a significant chunk, right, of research and development budget away from military R&D, away from polymer R&D, right, plastics R&D, genetically modifying foods aren't, I'm not saying eliminate all those fields completely. Heaven forbid, okay? What I am talking about is diverting chunks of those resources, appropriately selected, including not just the financial resources, but the human resources, right? Find some of the best and most relevant minds, creative minds, and get them together and give them some serious resources, some serious headcount, and some serious budget, for example. Anyway, I could go on and on about that, but let me go back here, back to the map, and then I want to talk about some real life experiences of mine in the realm of modeling and optimization. Let's see here. So, okay, but back to the simulator. Optimization layer to help us determine the optimal set of solutions. Again, at any level, from conceptual all the way through detailed design, right? Imagine there's a whole railroad. Anyway, the goal of this modeling and optimization is, among other things, is to determine the optimal set of solutions, the optimal deployment plan, and the optimal sequence. That's right, I was talking about the sequence of what happened in Singapore. From when their government budget was minuscule, right? They couldn't just, it wasn't just like, oh, let's go build airports and deep water ports and railroads and no, they had to phase it in, right? So there's an exact sequence to things. And then look at all the failed economies around the world. right? The so-called, I don't even want to repeat stupid names, but countries that are in really bad shape, right? Some very poor or simply very corrupt planning and execution happen in those countries. Anyway, bottom line, modeling and optimization matters, and it matters a lot. So, so much so that I was so inspired by Doctors Fogel, Dr. Lawrence Fogel and his son, Dr. David Fogel, at the company Natural Selection Incorporated. Can you see this okay, Michael? Can you see the Zurich on there?
Yeah.
Yeah, that I built a bit of a career around modeling and optimization. So that when I was at Microsoft as corporate strategy manager, I proudly working in Alex Ganara's group, who later became chief technology officer for the company. I presented the concept of data-driven optimization of all of the company's online networks. And this is generic enough that I'm not, spilling any secrets or anything like that. But, let's take MSN.com, for example. There's so many different goals or, teloi, teloses, possible teloi, or combinations of teloi that we can have as the goal. And so I built a prototype simulator of both content and advertising. And anyway, to present that and the potential and the benefits of network optimization, I pointed to some notable examples from history, one of which I had the honor and joy, actually, of leading, which was the optimization of Cemex. For most years, the world's most years of recent history, the world's most profitable cement company. And, this is a really interesting, not rags to riches, but small riches to giant riches story of a relatively small regional cement company in Mexico in a Singapore-like orchestration of resources and relationships and strategic acquisitions and whatnot. So when I was a hotshot computer modeler and builder of optimization layers, they snatched me up and made me an offer I couldn't refuse, and went to work on building a model with an optimization layer to optimize all of their operational planning, production planning, logistics planning, inventory planning, etc. Basically, how much to produce of each type of cement at all the different 18 plants across the country, and of those 5 different main types, and of those volumes produced of those 5 different main types, where to ship them to, and via what combination of modes of transport: steamship, truck, bulk truck, rail, etc. All those, literally tens of thousands of variables, and so very positive results came out of that. It was a really interesting thing. But we literally optimized Cemex, and so then I said, well, why not use a very similar technology to optimize Microsoft's online networks, where the different stages are measurement, prediction, control, and finally optimal control. So you can imagine looking at the results of different versions of a homepage, for example, A/B testing. I took some of this stuff also to Optimizely, by the way, optimizely.com with a Z. Levers for defining, new versions of a page are our control levers. So you see, this is where we go from prediction to control. So if we can predict through measurement, through A/B testing, get the data, you were talking about large amounts of data, we then go from prediction to control, which is optimal control being the goal. So controlling content, controlling which version to display of each and every page of myriad pages, and essentially orchestrating the whole network for controllable outcomes within a range, right? No one's saying, oh, you can just work miracles here. No, we're just finding the best of whatever set of possible futures and being able to value each. And anyway, going through the whole math and the whole modeling of it. And so, as I was presenting this to folks, I get the question, well, how do we know this is going to work? Finally, I just sat down and over the course of a couple of weekends coded it up. And anyway, that's all I can say about it. But all that is to say that, well, just to complete the story, it was designed to maximize advertising revenue, not just among big paying clients, but smaller ones as well. And but also to optimize for search volume and revenue, and numbers of new users of what was then called Windows Live Services. And also include optimizing for marketing, optimizing all the marketing investments that we wanted to implement in order to generate all these positive outcomes. Anyway, in the end, the telos is really a vector of different measurable outcomes, okay, times essentially, and then you take a dot product of that, of the values of each of those elements, each of those variables or those outcomes rather, with a unit value to get an apples to apples comparison, and therefore the best possible total combination. But the simulator is the bridge between input variables or control variables and outcomes. And anyway, so really fun project. You got to know where you're going. That's the telos. So in summary, simultaneous optimize page design, content serving algorithms, ad order placement, house ad design and placement, marketing spend by partition to maximize the telos, to maximize the goal. Anyway, really fun project, super fun. And oh yeah, there's some kind of cool architecture stuff. Might as well finish the slide deck. And as I said, I finally built a prototype and showed how it works, proved the math, proved scalability. Anyway, so really cool project. Anyway, that's just some of my background in modeling and optimization. And it's just such a powerful tool set in what it enables you to do. I mean, we're talking about optimizing, multi-billion-dollar operations. And not just for money, but for lots of factors like we talked about. Anyway, I think do you feel like we've covered all the bases, Michael, or is there anything else that we need to talk about?
No, nothing comes immediately to mind.
Okay, let me just recap super briefly, because I know we've been on for a while. We started with where does this fit within the larger picture? Where does modeling and optimization fit within the larger goose that lays the golden eggs? Well, the goose is the capacity to generate the solutions, and that consists of 4 main parts: ideation, design, modeling and optimization, and finally implementation. So this is really, modeling and optimization is the filter between design, either conceptual design or detailed design, and implementation. Implementation of what? In the case of detailed design, it's implementation of it in the real world. It's ready to go, right? It's a golden egg that's ready to be laid, right? Versus conceptual design, like we talked about for fusion energy, right? Well, what's the implementation? The implementation is implementation of R&D, resource, people and money, and platforms for that matter. So anyway, you can imagine some of the best minds in the world, most relevant minds in the world, passionate about fusion energy, using collective intelligence to build out the various missing pieces, right? Just like getting ice off of power lines. That was a missing part of the design. Well, what's missing from fusion? Let's identify it and let's fill the gap. I mean, it's really quite elementary from that perspective. And then, so that's where modeling and optimization fits within the big picture. And anyway, we've taken some deep dives. We've looked at a lot of cool stuff.
Yeah, and with that, going back to the previous video we did on design, we've come full circle here, with the implementation. And then from the implementation, of course, it doesn't stop at that. The results get recirculated, through the collective intelligence, the network of platforms, with the global holistic modeling and all that, so that those set of results can be used to solve yet other problems.
Yeah, totally. Absolutely. And in fact, another thing I just want to highlight is the implementation of R&D budget. That's implementation, like in the case of fusion energy, right? You can see how the modeling and optimization can tell us just how urgently we need it, right? Mm-hmm. Because frankly, it may well be that we're hopeless without it. Now, do you think the oil and gas industry is going to want to hear that?
No.
And full disclosure, family assets are owned by our family are paying out some dividends in that department, which is a huge tragedy. But anyway, just full disclosure. So that all needs to be shut down and replaced with fusion energy. And we need to get on it ASAP. So to get there, modeling and optimization, both for detailed designs and for concepts. And this is us literally going inside the machine, going inside the computer in the virtual realm. And, running these simulations, these experiments, just purely inside the computer. It's extremely powerful, leveraged properly. And then I talked about some of my own experiences at CEMEX and at Microsoft, designing and implementing systems for modeling and optimization. And, just all the potential of all that. Super cool. Anyway, anything more to add on this, Michael, or questions or comments or anything?
No.
All right. Well, it has been an awesome pleasure as always. Really great work, Michael. And thank you all. And please participate. Join the conversation. Please post your comments and or questions on this YouTube video. Thank you so much, and we'll look forward to seeing you next time.